Vice Admiral Vatsayan, senior officers, dignitaries, industry partners, academicians, media personnel, ladies and gentlemen. Good morning. Jai Hind. Well, at the outset, I would like to thank CISC and Sanjos for having organized this event on such a seminal topic and having given me an opportunity to express our views on this. So the topic which has been given to me is the problems experienced or envisaged by users due to use of imported components in US and counter-US way forward. Well, while this is the overall topic, you just heard the CDS also. Primarily what is going to be covered by the panelists in this is about the user requirements. And we have the panelists from representing all services and also from the paramilitary forces. So before they are called upon, I would just like to briefly cover on this aspect as to why are we talking about this. Is it only the indigenization part, the Atmanirbharta part, or is it something more than this? Atmanirbharta, we all understand why it is required, but that is what we have been talking about for all kinds of equipment. And that's equally applicable in this domain also. But what is more peculiar, why to have a separate session and so much of focus on this? Is it just because we have seen their employment in the recent conflicts? Well, that is also one of the reasons. But more important than that is that the kind of vulnerabilities which these systems have is what, whereas it is your tool, it can actually be utilized by the adversary as a tool against you. And that is what we have to guard against. And that's the main reason why we are talking of that how to reduce this import dependence and what all kind of issues we can have. And why I say so is just to give a brief background to that. We all know it, it's a known fact that most of the drone components, especially the semiconductor, the chips, are all made in China. And the problem is where? Problem is because in 2015, China has passed a regulation. There is their cybersecurity and data privacy laws and regulations, which they call it for the purpose of military-civil fusion, which mandates all Chinese firms for all their products being made to provide data access to data collected within China and around the world. Which means any of the components, any of the chips coming from China are likely to have this facility wherein the data can be collected and which can be accessed by Chinese. Now how it can be accessed? Whether in real time or at a particular frequency or by some other means once it is connected to the internet and things like that, that's a matter of debate. But yes, there is that means a provision surely wherein the data is getting stored and it is vulnerable whenever it gets access to. So that is one major issue which we have to guard against. And we have seen this in use in all these modern warfare, including ops and drone. So the importance is of developing a truly indigenous drone ecosystem to avoid the dependencies on the foreign suppliers and obviously then enhancing our op capability. So how do we do it? Why do we address the vulnerabilities like communication breach, the data exfiltration or navigation spoofing? Second is that we address the indigenous challenges because we know as of today what the status of our indigenous industry is so far as actual designing and manufacturing is concerned and not talking of integrating it. And of course, the supply chain vulnerabilities I've already mentioned. So therefore, the need is actually to arrive at a practical and implementable kind of regulatory framework so that we are able to draw a balance between our requirements and the present ecosystem. So to do that, firstly, what are the threats to drone systems? You need to look at that. I'll not go into the details of this. I think they are quite self-explanatory, and having gone through this entire thing, especially in about last 3 months, the way we have been discussing about the drones and all, but primarily is the interception of communication links, which can even lead to hijacking the frequency used for communication. Jamming spoofing, we all understand that. Controlled hijacking, when they take over gain the control over the drone's navigation, and even maybe if required the payload also. Data exfiltration, I've already mentioned about it. Patching and firmware updates, because if anything, the firmware which is coming from this getting automatically updated And in update, what kind of vulnerabilities are also actually getting injected is something really difficult to ascertain. And then, of course, it acts as a broader surface for data collection because it's not only in the military, but it is a drones being used across the country by all various ministries for different kind of applications. May it be, say, agriculture, may it be mining, may it be, say, for even the monitoring of the electrical cables or any kind of thing. So imagine the kind of data which can be actually collected because of the Chinese components. That is one aspect, or even if we say some other foreign components can be. Okay. So therefore the need is actually to see that what all are the components wherein these vulnerabilities can come in. We all understand this drone system architecture, but I just focus on some of them because it's not that the entire drone or all the components should be non-Chinese. Anything which cannot transmit data or say store data or transmit data or can be taken control of is actually, even if it is Chinese, it does not make any difference. But it is those components, those critical components. So what are those kinds of vulnerabilities in the drone systems? Yes, 7 of them, if we look at them at component wise. And the electronic speed controllers, because if they take over they start controlling the speed over BLDC motors, the whole platform can become unstable and actually get damaged. Flight controller, of course, design of microchip. If it gets manipulated, everything gets controlled from there. Transmitter and receiver units, because of the weak encryption and the insufficient authentication, would obviously allow attackers to intercept the data. And spoofing, of course, because of the INS and GPS systems. Sensor units. Now, if there is an access to those sensor units, the data being collected can also be not only transmitted, but also can be actually manipulated. So what data we want to actually see, whether we are seeing that, what is there actually the sensor is observing or not, is again a question mark if it gets manipulated. Ground data terminals, because they can be compromised through the various subcomponents of the ground communication controller. And of course, the flight controller firmware and all, which is prone to hacking and control the drone as such. So if we look at this, the various critical components are primarily these 7 of them, major ones in all drones. And I'm restricting myself to drones only. I'm not talking of the UAVs, that means not of the hail and mail class. I'm restricting only to the drones. But to start with, that's what we are focused upon at present. So therefore, what is our mission and approach? To have minimum supply chain disruptions, of course, from the logistical perspective, but more important is to have zero risk in drone systems. So to do that is what actually for about last 7-8 months we've been working on it, and we evolved a drone framework by having multiple stakeholder interactions, discussions, brainstorming sessions, starting with the first one on 3rd of October, one full day of event in collaboration with the Drone Federation India. We had conducted called a Drone Shiver. Thereafter, we had evolved something, made a draft document, discussed with the industry in this very hall on 20th December, not like a seminar, but actually a brainstorming. And then thereafter, again further on 3rd of January, we had more discussion on this. And apart from this, one-on-one meetings with all kinds of agencies, involving the various ministries, that is the Ministry of Civil Aviation from METI, and the various say quality control agencies, right from STQC, the QCI, DGQA, DGAQA, SEMILAC, and all such agencies. And also the industries, especially like the Semiconductor Lab, Chandigarh, and various other drone industries who are experts in this. So if you notice here in the table given down below, actually broadly speaking, that we have been actually reducing our participation, because as we are calling after the first session, only those with whom we can have actually a meaningful discussion who are actually contributing towards this entire framework. So after having done all this is what a draft document has been actually prepared. And before I come on to the draft document, when we look at it, addressing security vulnerabilities, how do we do it? The simple thing is that you see whether it is a Chinese component or not. That is what generally everyone feels. But even to identify whether it is Chinese component or not is a big challenge. Because if you start start tracking the supply chain, In that, guys have to go down to level 6, 7, where it's actually originating from China, and they are getting routed through multiple countries and then coming to us. So therefore, it's very, very difficult to go down to that level. And a visual inspection of the components, of course, cannot be again foolproof, because there are all possibilities that even the components being manufactured in China but having stamp of made in India. So therefore, supply chain actually traceability is almost at present with the present system, unless we come out with some that kind of deep or say dark web extraction, it is something which is a challenge as of today. So therefore, then what is the solution? That means, should we have all indigenous components? But is there a guarantee that even if when you have indigenous components, that it will be secure? No, may not be. Because still, there may be some firmwares wherein again they are vulnerable. So even by saying that if it is indigenous and ascertaining that okay, every component is indigenous, to say that whether it is secure or not is a question mark. And then, what is the present capability and the capacity we have in the country for the indigenous manufacture? Because if we do not have it to the level which it is desired, then of course we have to for some time remain dependent on the imported components. So to draw a balance between all these things is what a framework has been evolved. The aim is that we carry out a testing or the validating in such a manner that we ensure that it does not have any vulnerabilities related to the security. That is, to those aspects of, say, data theft, the communication, and the hijack control. So this framework has been evolved and is under approval by the competent authority. But what will it imply? It will imply at the RFI and RFP stage, we're going to give the list of the tests which are going to be done. And then the vendors who are responding to it have to accept that yes, they are ready to make their equipment go through these tests and share the related documentation with respect to it. How to share or only show is a matter of detail, because we understand there are a lot of discussions on the IPR aspects and all, but there are ways and means of it, how that IPR can be guarded and how that physical actually thing can be seen by both of them sitting in front of each other or at the vendor's premises and all, instead of actually sharing and handing over the document to the person, the agency who is actually validating it. And so during the trial stage is where all these tests are going to be conducted. Once the tests get conducted during previous stage, as it happens with all our equipment, based on sample size, some confirmatory tests will be conducted. And post-contract, the firmware and patches updates by a vendor regularly. And yes, in case in this entire process, if anywhere it is found that somebody is fabricating, falsifying, or forging the documents with respect to these critical components, then they are liable to be blacklisted. Because like I said initially, it's a matter of national security. So it can't be taken lightly like any other equipment. And we'll maintain a centralized database of it so that next time, if that same component is getting used in some other product, it does not have to go through that testing again, but we save on time also on that aspect. And for this purpose, we already got one particular system having gone through this entire process, and we've been able to validate that yes, whatever tests we evolved are actually doable, they are workable, and they're able to give us the kind of results which we are looking at. Which is just a snapshot of, say, one of the tests, that how it is covered in the framework, what are the kind of vulnerabilities, what tests to be done, what are the testing parameters, and what kind of documentation is required to be submitted. So this is what, once that framework gets actually in the open media, the approved one, though already most of the industry has it, those all who have been participating with us, but the final version of it, with some amendments, is what will come out once it gets approved. So if we talk of indigenous manufacturing, during this entire process, so because of our interaction with the industry, we realize that there is, I think, no component which is actually not getting manufactured in India, leaving aside, of course, the semiconductor chips. And this is what our database shows, the number of various industries actually making these indigenous components. But then, where is the problem? The problem is that firstly, own industry is not aware of these indigenous manufacturers. That is where the first problem lies. The second one is that yes, those who are manufacturing, do they have the capacity to manufacture in bulk? May not be at present. And if they don't have it, why so? Because they haven't got the orders. They'll get the order only once the awareness is there like that, and it is actually enforced that only these indigenous components will be used. That's the only way that they will start getting the orders, and then the capacities will start getting developed. So this is one issue which needs to be actually looked at in the larger context, which requires various kinds of actually policies and all. But one more aspect, apart from the drone as such, since we are using them for as a kamikaze and all, about the explosives. Now this is a bottleneck which we are facing with the Indian industry at present because of the lack of industrial licenses for the explosives. There are very few who are able to supply us the loiter munitions or the kamikaze drones. But when we further delve deep into it, there are 42 industries who have the licenses for explosives. But practically, there are only 10 of them who are actually making it. There are 32 of them who have got the licenses but are not actually utilizing it. So I would urge the industry that all those who are not doing it, there is a large scope for it with the kind of our requirements we are going to have in future. So please start getting into this explosive thing. And also to be able to actually overcome this problem, we are also working upon having some sort of standardized explosives so that we tell you that okay, there is the explosive to be used, and now you please give us a board which can use this explosive. With some common interfaces and protocols worked out in that, with a common fuse and of various explosive sizes and various kinds of effects which are desired from that, whether anti-personnel, anti-structure, anti-armor, and so on. So this we have just started with this process so that we can then either have it as a buyer furnished equipment or as a buyer nominated equipment. So the thought process has just started. We're going to get into the action for this. And finally, as it's not only the military, it has to be a whole of nation approach. Getting back to what I mentioned initially about the capacities, the orders. Because that capacities, if someone has to compare with it, because of the procurement process being L1 driven, so therefore it's much easier to get a component from abroad, easier and of course cheaper to get the component from abroad vis-a-vis getting it from an Indian manufacturer. So that is where to become an L1, obviously the industry is not incentivized to go in for the indigenous components. So that is where some policies are required at the national level, some kind of incentivization, some kind of equivalence factors to be worked out for an indigenous component vis-a-vis an imported component, so that this L1 business is actually adequately addressed and the industry actually starts using those indigenous components. And that will alone also, again, may not suffice by only meeting the military's requirements. Like I said, the threat, while we are now at present looking only at the military, but yes, in the larger context, it is for every sector, and that is where we need to look at, actually, ideally speaking, all the drones in every sector, all drones being used in India to be indigenous. So that is where all other ministries also may have to then implement this kind of framework, wherein with this, then only those quantities requirement will increase, and then that capacities will automatically be able to match that requirement of the L1, and all the cost effectiveness will automatically come in. So that's where again the thought process is on for this also. There are discussions going on, and I'm sure in times to come we'll be able to come out with something which is more workable and finally have indigenous components. I will end here only. Just mention one aspect before leaving, though because the detailed requirements are going to be given by the respective service headquarter reps, that whatever drones and now what we have learned, especially during Operation Sindoor, they got to have 4 or 5 features are almost a must in each one of them. Anti-jamming, anti-spoofing, ability to function in a GPS or GNSS denied environment, and ability to avoid cyber takeover. So these are some of these main features which are required to be part of each and every drone. So that's why again I request in the industry, even in the ongoing cases, especially if the Indian Army, we already have discussions with the vendors and requested them, even if they were not given in the initial PDS, PRE or in the PSQR, please include them, because without that these drones, the efficacy is actually very, very doubtful. So with that, I will finish here, and now I'll request Colonel Sehwal to start with the requirements of the Indian Army. Thank you.